Good afternoon, class. Thank you. You can sit down. All right, then, as we said last lesson, our lesson today is going to be on areas and perimeters of different figures and shapes. And you have been working in groups. You will have to present that to the class. And when you are presenting, remember, you are teaching your peers. That means you've got to, you know that you have to get the formulas for the areas and perimeters correctly. Group 1 is doing an introductory lesson. So you're supposed to define perimeters and areas as well. Okay? But before we do that, we have to go through the exercise that you were given on conversions of units. Okay, have a look at the exercise. All right, question 1, we looked at letter D. The answer we got was 0.0043 square meters. All right, we're going to go through the class and see what answers you have for the rest of the questions. Number 1A, we'll start from Taumaku. You have to change 832 square centimeters to square millimeters. Please, your answer. 83,200 square millimeters. Very good, Kyle. B.
30,000 square centimeters.
30,000 square centimeters. Letter C, Solomon.
500,000 millimeters square.
500,000 square millimeters. Okay, you all agree with those answers? If you disagree, just say so, please. Question 1, letter E, we.
20,000 square meter.
20,000 square meters. Gabriel, letter F.
2.789 hectares.
2.789 hectares. Okay, correct. Letter G. Kiapin.
450 hectares.
450 hectares. Are you sure? 450 hectares.
Yes.
Okay, I think the answers that I've got there is wrong. Are you sure it's 450? Yes. Okay. You're smart. 450 hectares. Okay. Number 2, we're now looking at the units of volume. Letter A, 3 cubic meters to 2 centimeters cubed. Miriam?
3 million cubic centimeters.
3 million. Okay, 3 times 10 to the power of 6 cubic centimeters. Correct, Chutaili? Letter B.
0.00435 cubic meters.
All right, 0.004352 cubic meters. That's correct. Megan, letter C.
0.0004 cubic meters.
0.004 cubic meters. Correct. Hekoi. 2D, we did. Yours is 2E.
0.03 square cubic centimeters.
0.03 cubic centimeters. Yes, correct. Letter F. Velma.
0.000205 cubic meters.
Okay, hopefully I've got that. Yes, 0.000205 cubic meters. Any questions so far? No? Good, you're all experts. Letter G.
0.5 liters.
0.5 liters. Yes? Jake, H.
375 cubic centimeters.
375 cubic centimeters. Okay, 2G should be 0.5 liters. 2H, 375 cubic centimeters. George, letter I.
125 milliliters.
125 milliliters. Is that the last one for number 2? Okay. Number 3. Now we're on to the unit of speed. Andrew, letter A.
20 meters per second.
Correct. Letter B. Peter,
60 meters per second.
60 meters per second is correct. Letter C. Gabriel,
86.4 kilometers per hour.
86.4 kilometers per hour is also correct. Letter D we did yesterday. Did we do letter D in our previous lesson? Okay, sorry. Letter E, the answer is 1. You can have 1 2/3 or 1.66 recurring or 1.67 to 2 decimal places. Sorry. 16 2/3. Okay. My second mistake. You win. Okay, letter F. Conrelay.
1.5 kilometers per hour.
1.5 kilometers per hour. Are you sure? Agnes, what's yours? Raylene?
$90 kilometers per hour.
90 kilometers per hour is correct. Okay, note. For letter D, 3D, the answer that we got in our previous lesson, was it 3.6? Okay. Letter E, it's not 1 2/3, it should be 16 2/3 meters per second. Any questions? You're all smart, huh? Okay. Next, we are now going to look at the formulas for the perimeters and areas of different figures and different shapes. Now, group 1, you are going to come and tell us the formula or teach us the formula for finding the perimeter and area of a square. Once group 1 is done, group 2 you have to come. You need 2 people, 1 to help with the sticky taping of the chart on the board. So please, group 1, whoever is presenting for you, come now. And if you have any questions to group 1, please put your hand up and say so, if they don't explain very well. Is there anyone else ready apart from groups 1 to 4? Jake, you ready? Are you ready? Huh? Because we might have to do more than 4. The mic, where's the mic? Where's the mic? Relax.
Our presentation is on area and perimeter. Definition of perimeter is the total distance around a shape or the length of its boundaries. Area is the amount of surface or the size of a surface. Note that area is measured in square units, example centimeters square, meter square, hectares or kilometer square. To find the perimeter of a square, the formula is P is equals to 4 times S, because there's 4 sides, there's 1 length given, or you could add all 4 sides. Our example find the perimeter of a square with sides 3 cm. Since P is equals to 4S, then 4 times 3 is equals to 12 cm. For area, formula is equals to A is equals to S square. That's square this times this, which is the same as this. So example is find area of a square with sides 3 cm. Since area is equals to S square, we just squared 3, which is therefore equal to 9 cm squared.
Give them a clap. Any questions? You supposed to any questions? You're going to ask any questions?
Our group is looking at the area and perimeter of a rectangle. Okay, we've just got a definition, a simple definition of a rectangle there. A rectangle is a quadrilateral in which all the interior angles are equal to 90 degrees and the opposite sides are of equal length. Okay, the shorter sides of a rectangle are known as either the breadth or the width, and the longer sides are known as the length. Okay, the formula for finding the area of a rectangle is L times B, which is length times the breadth. And the formula for finding the perimeter is 2L plus 2B. Because there are two breadths, you times one breadth by 2. And because there are two lengths as well, you times the length by 2. And then you add them to give the total perimeter. So our example is based on this rectangle. So to get the area, because it's length times the breadth, we used 5 times 2 to give us 10 square centimeters. And for the perimeter, because the formula says 2 times L plus 2 times the breadth, we times 5 by 2 and 2 by 2, and we got 10 plus 4, which gives 14 centimeters. Any questions?
Clear? Good one. Next.
Our topic today is based on rhombus. Definition: the rhombus is a parallelogram with all its sides equal in length. It possesses all the properties of a parallelogram, whereas the parallelogram has no axis of symmetry. The rhombus is symmetrical about each of its diagonals. This leads us to two further properties.
It has two properties, which are one, triangles A, B, and D are and BC and D are congruent, Hence, triangle ABD equals to triangle DB and C, and angle ADB is equal to triangle VDC. And property number 2, the diagonals bisect at right angles. So if the triangle ABD is equal to triangle BCD, we can say that the area of the rhombus can be as follows. Area is equal to 2 times area of one triangle. Therefore, it's equal to 2 times half base times height. And because all sides are equal, we can say the perimeter of the rhombus is 4 times S, which is similar to the square. Given the dimensions, find the area and perimeter of the rhombus. Area is equal to 2 times half base and height. So area is equal to 2 times half times 10 times 6, which is equal to 2 times 30, which is equal to 60 centimeters. 30 is multiplied by x because there are two triangles in a rhombus. And the perimeter is equal to 4 times s. So 4 times the side, which is equal to 8, is equal to 32 centimeters. Thank you.
Wait. Leave it. Okay. There is another formula that you can use to find the area of a rhombus. All right, just have a look at this one. In the property, they said that the diagonals bisect each other at right angles. Have a look at the example. If this is 8 and this is 6, okay, using Pythagoras theorem, this length would be what? Are you sure? Six, 8, 10? Is it 5? Come on. If this is 6 and this is 8, the diagonals bisect each other at right angles, which means this angle is supposed to be a right angle. If that is so, if this is 10, then this is 5. Does it agree with 8, 6, and 5? Okay, if it's a right angle triangle, then you're supposed to use Pythagoras theorem to be able to find this. Maybe the group that did this were not aware of that, but it should agree. If this is 6 and this is 8, then you should be able to use Pythagoras theorem to find this one, and then multiply by 2 to find this side. But what they did was they got the diagonal to be 10. Okay, the formula that they've used is twice half of the area of a triangle, which is they found the area of one triangle and found the area of the other one and multiplied that by 2, and they got 60. Okay, they said 10 is the base and the perpendicular height is 6. Maybe the measurements that they gave, it's actually not correct according to the properties of if you are going to use Pythagoras theorem. But the formula that they've used is correct. Now, there is another formula that we can use to find the area of a rhombus. If you know the length of this diagonal and the length of this diagonal, the area is actually equal to half of the product of the two of the diagonals. So it's, if I call one diagonal 1 and the other one diagonal 2, then the area of a rhombus is equal to half of diagonal 1 times diagonal 2. You can actually use the same formula to find the area of a square. You can prove it. You can also use the same formula to find the area of a rectangle as well. If you know the diagonals, you can actually prove that the areas of those are equal to that. Now we specifically use it for a rhombus because the lengths of a rhombus do not meet at right angles. So that's just, instead of having to use this formula, you can also use that if you know the diagonals. Okay. For the example, what you can do is find out that if this is not 10, you can try and use 6 and another 6 there, and then if you find this diagonal, you can prove that the area for this one. The area might not be right because of the wrong measurement that they've used here, but the formula is okay to use if you know the base and the perpendicular height of one of the triangles. Okay, is that clear? All right, next group. Mr. Pointer.
I would be talking about the kite. The definition of kite is, it is a quadrilateral having two pairs of adjacent sides which are equal in length. This means that the two short lengths are equal, these two, and the two longer lengths are also equal in length to themselves, these two. A kite has a line of symmetry, which means the length over here will be the same as the length over here. So to find the area of a kite, we add the area of triangle A and the area of triangle B. In this case, the top triangle is area A and the bottom half is area B. So we use the formula of triangle, which is base times height over 2. The base will be 30 because we will multiply 15 by 2. So 30 times 20 divided by 2 is 300, plus 30 times 36. We got 36 by subtracting 20 from 56 to get this length. Divided by 2 is equal to 540. And when we add the two areas, we get 840 square centimeters, since the unit is in centimeters. To find the perimeter of a kite, we multiply the shorter lengths by 2 and the longer lengths by 2. So in this instance, we haven't written down the outside length, so we'll have to use the Pythagoras theorem. So 2 times 15 squared plus 20 squared, we will find this length. And 2 times 15 squared plus 36 squared, we will find this length.
Okay.
So when we added the two squares of this, we got 625, which is equal to c squared, and 1521, which is equal to this length squared. And we found the square root of these two lengths. And the square root of 625 is 25. The square root of 1521 is 39. So we multiplied the lengths by 2, and this also by 2. So we got 2 times 25, that's 50, plus 2 times 39, that's 78, which is 128 centimeter is the perimeter of this kite.
Punrile, leave it first. Leave it first. Okay, You will also note that, that for the kite, you can also use this formula. Okay, let's just prove that. This is 36 and 20, so that the length of this diagonal is 56. Okay, so we get half of diagonal 1 is 56 times diagonal 2, which is 30. If you multiply 30 by 56 and divide the answer by 2, you get 15 times 56. I hope it's 840. Okay. If you know the diagonals, instead of having to find the areas of 4 triangles, you can just use half diagonal 1 times diagonal 2. Thank you, Pond Relay. Well done. Any questions you want to ask the different group members? Remember, those are the notes that you will get. I hope you were taking notes while they were talking, because I am not going to explain further the areas of the different shapes that we've looked at. Okay, we are supposed to do the area of triangle and a circle and a sector. That's group 5, group 6, group 7, group 8, and group 9 is made up of 2 people. Any of those groups ready? Because I said we will do group 1 through to 4 will present theirs today. Jake and Boromeo, are you ready? No chat. Can you come and do it on the board? Because we have time for one more. Come and try it. Group 5, are you willing to present yours without a chart? Just using the blackboard. What's yours? Trapezium? Kila? Or you still want to do that with a chart? Huh? You'll do it with a chart. Okay. I expect group 5, group 6, group 7, group 8, and group 9 to get this prepared by the next lesson. Okay. Plenty of questions. Okay, you can't, I'm just trying to show you the exercise you are going to do based on areas and perimeters. Because you can't, the exercise has a combination of all the different shapes and figures. I'm not going to give you a homework today. You will have to do the homework after everyone has presented theirs. So those people who are presenting next lesson, yours should be better than those that presented theirs today because they had only 1 day to prepare. You have 2 days. Is that okay? All right, so I'm going to let you go to your next lesson. There is no homework for today. Your homework will be done when the others have presented theirs. All right, I'll have to let you go to your next class. The keyword to the pilot teacher is shapes. Thank you. You can go.